Good morning students. Today in this session 3 we are going to learn in depth of aggregates, which is the second main component in the concrete, where cement has given the first priority. We have given the second priority to the aggregate. So here in aggregates in session 3 we are going to learn about what are the contents of the aggregates. So aggregates, generally classification of aggregates is a two shape based on the shape and size. So natural stone aggregate, good qualities of an ideal aggregates, mechanical properties, tests on aggregate, and bulking of sand. So introduction: filler with finding material, derives from rock, form body of concrete, reduces shrinkage and affects economy, occupies 70 to 80% of volume in the aggregate in the concrete. Important to obtain good quality of aggregates: no chemical insert, chemical active in exhibition, chemical bond at interference of aggregates and cement paste, securing volumetric stability and durability in the concrete. So what are the classifications? So broadly, aggregates can be classified of two types, which we already discussed in the previous classes. The first one is fine aggregates. So generally we consider 4 mm, less than 4 mm is fine aggregate, but technically when we talk about as a civil engineer, we used to take that less than 4.75 mm is considered as fine aggregate, greater than, which is retained on the sieve, like 4.75 mm or greater than 80 mm, we consider as coarse aggregate. So if you see the picture of this, we can see like coarse aggregate to fine aggregate. So this is the picture. So coarse aggregate, so these are two types. There's a smooth finished and rough finish. Generally we go for rough finish to get a higher bondage in the aggregate, concrete, sorry. So the flakiness aggregates, elongated aggregates, there are different types where we used to use. So the percentage of aggregate we used in concrete can be based on all stones, or all the aggregates should not be in a round form. Say shape and size of the aggregates will also impact that. So if you take the aggregate specific gravity, unit weight, bulk density example. So if you see, normal weight of the specific gravity is 2.5 to 2.7, 23 to 26. It's like Newton, kilonewton per meter cube, kilonewton per meter cube for bulk density generally. For sand, how much? For heavy weight, scrap iron, how much? And lightweight like dolomite, what is the specific components which we have in aggregate? It's a general thing. So surface texture, smoothness and roughness classification can be based on the glassiness, smooth, granular, rough, crystalline or honeycombing or porous. So generally we go for the rough or not more than as a sandstone, because the strength will give on the surface of the based on the roughness of the surface. So good qualities of an ideal aggregates are: it should be consists of natural stone, gravel, sand or various combination of this material. It should be hard, strong and durable. It should be dense, clear, free from any coating, and it should be free from injurious vegetable material, and it should not contain flaky elongated pieces, because based on the pieces elongation based on the piece of higher length, which will not give higher strength to the concrete, and it should not contain any material liable to attack steel reinforcement in case of reinforced concrete. So generally we go for the natural sand, natural stones rather than the artificial one, and that should not be with interacting with any of the vegetable materials or injured vegetable materials. So next one is the strength of the material is, strength of the aggregate is, it should be equal to the concrete, and crushing strength is more reliable, toughness of impact test, hardness of abrasion test. So we used to do many tests on the aggregate. The first one is strength. So what is the strength? So shape and texture. Based for shape and texture, we influence round and irregular are highly workable but yield low strength. So flakiness requires more cement paste. So which produce maximum voids. So that's why we avoid the tricky type of aggregates. So angular shape is best, and shape and texture governs with water requirements, so which gives the govern requirements. So specific gravity lies between 2.6 to 3.5 for natural aggregates. So generally we take in between 2.6 to 3.5, which is other than this range we consider it as unfit for concrete. So lower the specific gravity gives higher porosity, therefore poor durability and low strength. So density greatly depends upon specific gravity. So we are going to see the specific gravity in a certain range where the strength of the concrete will enhance. So bulk density and voids depends upon particle size, grading and moisture content. The bulk density and voids can be formed, and that can be manageable. So if voids are more in the concrete, the strength automatically will reduce. Porosity, the entrapped air bubbles in the rocks during their formation leads to minute holes called as pores or cavities. So generally that should be less than 20%, because more than 20% gives air more gap, and the strength of the concrete, the soundness of the concrete will reduce, and the design period which we go for the construction will also be reduced. So moisture content, a high moisture content increase the water cement ratio to an appreciable extent. The surface moisture expressed in percentage of weight of saturated surface dry aggregates is known as moisture content. So thank you. This is all about aggregate. In next class we are going to learn about special concrete which is used.